Hey there. Good morning, everybody. Good afternoon or good evening. I hope it's not too late there. Remember, this is all recorded. Yeah, I hope we're all having a wonderful day. And I've got a very special guest here. We got Felienne. Hey,
Hello,
good
good
to
morning.
see
Well, for
you.
me, it's morning. Good everything to everyone.
And we got folks enthusiastically telling us good morning and where they're tuning in from. We got folks tuning in from London, from Spain, from Ireland, from Nigeria. So glad everybody's here. We've got a very special session for you today. We're going to talk about how to read code. Well, I'm going to be very attentively listening about how to read code. Oh, good morning from Ukraine. Hey, Sasha, good to see you. From Ethiopia. Oh, so good to see folks.
Truly
Yeah,
global. I'm impressed.
these learners are tuning in from all over the place. It is absolutely wonderful. From Cape Town, from Zimbabwe, from the Netherlands, from
From the Netherlands.
Seoul.
I'm in the Netherlands.
Yeah. Ah, wonderful. Yeah, so I'm gonna briefly introduce you, Felina, and let you tell us all about how to read code. So briefly, Felina here is teaching at the University of Leiden. You've written a book, The Programmer's Brain. Um, which is just amazing. And you've created a programming language called Hedi, which, now correct me if I'm wrong, uh, is intended to allow folks to write code in their own language, spoken language. Is that correct?
That's one of the aspects of it, for sure.
Yes.
Yes.
Oh, wonderful. I want to I definitely want to hear more about it. Um the way this is gonna work, folks, is please Faylene is gonna very kindly show us a presentation, and there's also gonna be questions from all of you. So feel free to ask them, and I'll very briefly interrupt Philenis so she could answer them. So please keep those questions, like get those questions coming, and yeah, it's gonna be wonderful. And again, thank you so much for being here. I'll let you have at it, Philina.
Thank you so much. Thanks for having me. It's really exciting for me to give a talk this morning. My name is Felina. I'm on Twitter as well. I don't know if people are still on Twitter, but if they are, my handle is very conveniently my first name. So if you want to follow me on Twitter to see what I'm up to or talk about this talk or other things I do, then you can mention me with my handle. The topic we're going to talk about today is how to read code. And I know a bit about how your bootcamp is structured, but I don't know everything. But in general, if we teach people programming, whether this is in university or boot camps, very often there's a lot of focus on code writing. We write code a lot, and code reading tends to be a little bit overlooked. So, this is why I am so interested in figuring out how to read code. In order to understand a bit for you, so how I got interested in this, we have to go back to the year 2013 when I started to teach programming to kids. This was in a community center. Kids were sort of interested to learn programming and they needed a teacher. And I was like, sure, I can teach children programming. And at this point, I had just finished my PhD in software engineering. So I knew programming. And I thought this would be easy, right? Because I thought these are little children, 10, 11, 12-year-olds. How hard can it be? I know everything about programming, or at least I know more than a 10-year-old. So this will be easy. And I guess it shows that I didn't know anything about teaching at that moment. So, but I thought it will be easy because, yeah, how hard can it be? And what happened is that I sort of subconsciously started to think back up to how I learned programming when I was a kid. So this is me when I was a 10-year-old sitting behind my dad's huge computer learning programming. And at this point, this was like in the early 80s, there were not so many people that knew programming. So there wasn't an adult that was teaching me programming. I was teaching myself programming from books and other things I could, magazines, things I could get my hands on. So I never really learned what a programming lesson looked like. And this is actually true for many people, maybe not the people today here in the room, but many programmers that sort of my generation, people that are in their 40s now, they learned programming alone. They never really took a programming lesson. And therefore, it's really hard to know how to do a programming lesson if you never took one. I mainly learned from books like this, basic computer games. And then if you think this is actually a teaching book, if you opened the book, this is what it looked like. So just long lists of programming code. And as you can hear, I guess my native language is not English, it is Dutch. And I knew nothing about what those words meant, like coefficient and now print is the same word in Dutch, so that was okay. But if and while and do it had no meaning. So this is the culture, not just of me, but a bit the culture of programmers in the workforce today, is that they all have such an experience, or at least many of them have such an experience in which they thought themselves programming. And this leads to the fact that many people that start to teach programming reenact their childhood, not intentionally, sometimes sort of accidentally. They reenact this, you just give kids programs and then they will learn. I'm seeing someone in the chat saying, I can relate. This is also how I jumped into teaching. So it's just like, this is not hard. Kids will figure it out. And I think secretly there's a layer underneath where we think, well, if you don't do it correctly, the compiler will tell you, there will be an error message and you'll figure out what the mistake is. I think we've all been Stockholm syndromed a bit into thinking that compilers are great teachers, which, maybe they're not. And you see this culture very, very visible if you look at teaching materials. I will show you some examples for kids, but I'm sure that some of the materials maybe you have also sampled on YouTube or on the internet, also to a certain extent express the belief that figuring out stuff by yourself is a good and fun way to do. The books will be in Dutch, but there's an English translation underneath for most people here, I think, that don't read Dutch. So here it says, the best part of programming is finding mistakes. This is sort of a special thing to say, right? The best part of programming is finding mistakes. I love programming. I program every day, but finding half of the time I'm the person that put in the mistake. I don't love finding mistakes, maybe fixing mistakes. So this is a special someone, right? That says, ooh, a mistake. This is a learning opportunity. I can learn from this. Here's another one. You'll fail often and it will be frustrating. We put this in books that are for kids. Hey, child, if you want to learn programming, you'll fail often and it will be frustrating. Welcome aboard. This is a certain type of person that says this. And also it attracts, of course, a certain person that will actually like this. Never be afraid to mess around and experiment, right? Figuring out stuff by yourself. If that's the way you learned it yourself, then that's what you think is the best way, because maybe it's the only way you would know how to learn. So this culture, not necessarily limited to educational materials for kids, also very present in educational materials for adults, leads to the idea that people just have to figure stuff out by themselves. Unsurprisingly, to people that actually know teaching, which was not me at the time, it didn't really work so well. Kids were not learning as much as I thought that they could or should learn. And I didn't really understand why. And indeed, I didn't know that much about teaching. And at this point, I got really, really interested in how people learn, because it was clear to me that it was me that was making the mistakes. These kids voluntarily registered at the community center. We want to take this programming course on our Saturday, on our day off. They could go play soccer or do whatever. And I said, no, we want to take a computer programming class. And then they weren't learning. So I couldn't say, hey, no, kids are motivated. Oh, kids these days, right? It was clear that it was my bad here. So I immersed myself into how do people learn anything? And specifically, how do people learn natural languages? Because I figured out that maybe we can learn something from how people learn to read and apply that on how people learn to program. So the first thing I figured out is like, well, but we never explain kids or people to read code. It's not a skill we even tell them how to do. I've seen undergrad students, so second, third year students, upon being presented with a piece of Python that they wrote themselves that didn't work. I was like, okay, tell me tell me what doesn't work. They just take their finger and they start reading at the top. And then they just go down until they, find maybe the location of the error. And first I was like, this is weird. But then I was like, well, I never told students what to do. How would they know how to read code? This is also very visible in the club. So sort of hypothetical, but also true situation that happened was a kid was like, hey, teacher, I made this program last week. And as you see, we use Scratch, which is a visual, colorful block for kids. Like, I made this program, but I don't really remember how it works anymore. Do you know what this does? Like, what does this code block do? And then I would be like, well, child, what do you think it does? Right? Because never be afraid to mess around and experiment. This was very much in my DNA almost, right? I really thought if I tell the answer, then this is cheating. Then the kids will not have fun if I tell them the answer. They have to figure it out by themselves, like I did in the 80s. But then the kid was like, yeah, I don't know, teacher. This is why I'm asking you for help. And then you say, I'm not helping. And if you compare that, of course, to imagine you have a kid that's learning to read and they see a word that they don't know. Your kid says, hey, what does this read? You will break up the problem in little steps, right? You say, hey, look at this first letter. Do you recognize this letter? It is the first letter of the alphabet. Maybe this is something you know. So you will also tell them, you can take your finger and you can do this, or you can cover all the letters apart from one letter with your hand and then focus on one letter and then do this. You give them techniques to read. Whereas with code, we just say, well, have you read it? Have you read it again? We don't really teach this. And it's interesting because it's not just about being in school, right? You might say, well, language is something we teach in school, so therefore it's very structured. But if you look at many sorts of hobbies, like playing musical instruments or playing sports, then there too, if you bring your kid to a guitar tutor or a racquetball tutor, then they will not say, here's a racket, here's a ball, go wild, right? They will say, these are the rules, and now we will practice service 100 times, or now we will practice one string with one note 100 times. So in all sorts of fields, we break up stuff into little pieces, and then we make bigger skills from little pieces. And then in programming, we're like, well, have fun, guys. I'm sitting in the back of the room drinking coffee. If you have a question, let me know. Programming is really weird that way. So that was the first thing I learned. We don't really deliberately teach, well, anything. Specifically, we don't teach reading code. The second thing, and now I'm really stepping away from my experience with children and going more towards professional practice, we professionals also never practice reading code. There's really nice research that says that professional programmers spend about 60% of their time reading code, not writing code, reading code. But then even as professionals, we have this idea that if you want to get better at programming, you need to do more programming, right? That, oh, I want to learn Rust. And then your programming friends might say, oh, that's cool. Why don't you build something? Why don't you build a little to-do app or something, or a little, I don't know, a little website, something. Just doesn't matter what you build. Just do something. And then you will learn by doing. Whereas, that's not necessarily true. It very much comes from this culture of never be afraid to mess around and experiment. I guess if you want to write, I don't know, a sci-fi novel, then maybe it's not a bad idea to read many sci-fi novels. You don't immediately start one. So it is something in our culture that we think getting better at programming is done with more programming. We recently had in December, of course, the advent of code, where we say, oh, as a community, we want to get better at programming by writing more code. So yeah, that says something, I think. The third thing, and now we're really going to dive into a little bit of cognitive science on the early morning for some, early evening for others. So I hope it's not too heavy, but there will just be a little bit of theory before we go on to the applications to programming. So what I also figured out while reading is that we don't really have really good theories for what happens in your brain if you read code. How to even read, if you want to get better, how to even do that. What happens in your brain if you read code? We don't really know this. So luckily, there's this famous German professor called Janet Siegmund. She does amazing work where she takes programmers and consenting programmers and puts them in an fMRI scanner to see what happens in their brains when they read code. This is like spectacularly interesting work, but this is still very early stage. And it's also very hard because in such a scanner, you can only have a few lines of code in a really little screen. So we as a community of scientists, we're going towards some understanding of what happens in your brain when you read code, but we lack really a theoretical model. However, luckily, we do know what happens in your brain if you read other things like language. There is quite some prior art already. So we can start by applying these things we already know to programming to help us better our understanding of reading code. And this is what we're going to dive in today in a bit more depth. If information enters your brain, what happens is that it firstly goes into your short-term memory, which in computer terms is a little bit like a buffer. It's a very, very small piece of storage that can hold only a very, very small subset of information. And we've known this for decades, really. Already in the 1950s, there was this researcher called George Miller that already said that your short-term memory is very, very small and might only hold between 5 and 9 elements. You might know actually this result because it's sort of a famous paper that's called the magic number 7 plus or minus 2. This is the 5 and 9 things that fit in your brain at the same time. And this might be a little bit abstract, right? What are 5 to 9 things? So we're going to do a little bit of experimentation on you subjects, where we're going to do a little memory exercise just to give you a sense of how little your short-term memory can actually hold. So what we're going to do, I hope you're all participating wherever you are. I will show a sentence on the screen, a brief 3-word sentence, very briefly, like half a second, and it's your goal to remember the sentence. And no cheating, right? No taking pictures, no taking screenshots. You have to use your brain power to remember the sentence. Here we go. So, any takers? Can anyone reproduce this sentence? Yeah, that was really hard, right? You're like, no, you are cheating. You told us no cheating, but you are cheating. This is not a sentence. These are just random characters. So you see how hard it is to store something in your short-term memory, right? And you look at it, you're like, oh, a triangle, oh, a stripe, and then it's already gone. It takes a really long time to actually process this. I see someone has 0 stripe 3. That's sort of quite good, still less than 5 to 9 elements, but you're getting there. With a little bit longer exposure, you could definitely remember a bit more. So you might realize that I am cheating by using a fake sentence in a language that I literally made up. This is true, right? And that is because it's just part of the puzzle, because your short-term memory doesn't work alone. Your short-term memory collaborates with your working memory, which you can see a bit as the processor of your brain. The working memory doesn't remember information, but it thinks about information. It processes it. And your working memory, whenever information is shown to the working memory from the short-term memory, collaborates with the long-term memory. So your long-term memory is a bit like an angel on your shoulder. Whenever you're presented with information, your long-term memory is like, hey, I have a thought for you. Here's some information that might also be relevant to you. It's a little bit like you go on Amazon, where your long-term memory says, hey, users of this information also like to have this information. So it gives you free information, which might be relevant, might also not be relevant. So knowing this, we will do another memory exercise, same exercise, 3 words, briefly shown, you have to remember it. And you will see a bit about the interaction between the long-term and the working memory on the short-term memory. Here we go. I hope you're ready. I see for some people it's really early, so I appreciate you going through these weird exercises with me. Here we go. So that was a lot easier, right? It was a lot easier than the first sentence. And I guess your angel on your shoulder was already jumping. It's like, oh, an A, a B, an M, a K. Hey, I know these letters. These are letters. Friend, wake up. These are letters, right? So something happens in your brain. And I guess it was a lot easier for you to represent to remember this information. And you see also there was a little bit of a trick there because it was ABK and not ABC. And this is where your long-term memory might say like, oh, ABC, right? I'm guessing what it is, while it was actually not. Oh, some really, really good guesses there in the chat. We will do one more. And I promise you that everyone that is awake with their eyes open can do the last one. And it will be also 3 words, also briefly shown. Here we go. So that was easy, right? Everyone got this, but it was just as long as the other 2 sentences. This was cat loves cake. Why was this so easy? Because your friend on your shoulder was like, I know this thing. And it didn't go like half a circle and a circle with a comma attached to it and a Catholic cross and a big stripe. It looks at the information and it immediately thinks of the image of a cat and of love and of cake. So it is really, really easy. And what I want you to take away from this talk until this point is that you see how much your prior knowledge influences what you see. Not even what you think, but literally what you can remember. So if you're working with someone that has a different level of experience, that knows more about a certain programming language or about a certain code base than you, or less than you, you're not even looking at the same thing, right? So you might be, if you're a more experienced programmer, you scan a piece of JavaScript and you immediately say, oh, this is model view controller, and this is where the initialization lies, and oh, they use a few libraries. You can easily process all these things because for you, it is cat loves cake. But for someone else, it might be literally a language that someone made up, like the first language I showed you. So I think this is often where conflict and confusion lies in reading code or working with code in a team. Someone will say, oh, but this is easy. And the other person will really have no clue. And it's not because they're not smart. You didn't get magically smarter in the 3 minutes between those 3 exercises, right? It has nothing to do with your cognitive abilities, and it has everything to do with your prior knowledge. So that's just something I want you to take away from this part of the talk, that if you don't have enough prior knowledge about something, it doesn't go into your brain. It's not because you're not smart. It's just you don't have the right prior knowledge. It doesn't attach to anything. It's just like it goes to receive. Yeah, these chunks, these parts, they call this chunks. They come from your long-term memory, and this is why it's so easy to process something. So I want to dive into code a little bit deeper. So mainly we've now had the intro cognitive science. Now let's look at what that means for programming, actually. And I want to talk specifically about how that lack or difference in prior knowledge goes towards different forms of confusion. So here's a program in a language called APL, which I think most people aren't familiar with. It's a really weird old mathematical vector-based language. And if I ask you to tell me what this means, then you're like, yeah, well, I recognize twos and I recognize n, maybe a number, but I don't know what the t is, right? So this is an issue in your long-term memory. You simply don't know what the thing is. You have no clue what the t means. It's not like there's not any other problem. You can grasp everything, but it's just the t that you don't know. Let's look at another different form of confusion. Here is a Python program. And if you're a Python programmer, this for you is cat loves cake. This is a very Python-like way of phrasing things. So it's called a list comprehension. It's a little bit like a loop or a map or a filter. It goes over a list and it filters out certain elements in the list. This, depending on your prior knowledge, can be either cat loves cake or it can be really, really weird. Because if you come from a Java or C-like language, this is not a syntax you're familiar with. And you'll be like, no, I see brackets. There's probably a list. You don't know exactly what goes on. And this has to do with your short-term memory, right? Because if it's not for you cat loves cake, then look at all the elements. Customer name, C dot first name for C in. You easily go over the limit of 9 things. So then it's just too much. It doesn't fit in your memory and you can't properly process it. So this is a short-term memory issue. Here, there's yet another different type of confusion. In this basic program, I'm going to assume that most of you have a sense what this does. It's not like the APL where you're like, what is this T? I guess you know what a let is. This is a variable assignment, and a for, that's a loop, and some calculations like multiplication and division. You know what it does. Part of the problem is that it is many elements, like the Python code. But then even if you get all the individual elements, it's still hard. Like, what exactly goes on here, right? You have this notion maybe of like, I don't know, let's take a value. Let's say n is 7. What happens then? Oh, well, and 1 is also 7. And this is divided by 2, so this is 3. Oh, so this is a string 1. It takes you lots of processing power. So this is code that's very hard because it's hard on the working memory. You just have to do a lot of thinking. You have the prior knowledge, probably, you know the things, you know what everything means, but processing is really hard. And I think because we don't talk about these 3 memory systems in the context of code very often, people get like, yeah, well, reading code is really hard because everything is so confusing. Like, yeah, but how are you confused? I don't know, everything's hard. Which sometimes leads to the fact, it's really annoying in different ways, that people then think it's too hard to understand this. I will write my own library, or I will rewrite this code that my colleague already made, just because they don't have the practice and they're not comfortable enough with seeing unfamiliar source code. But the happy news, let's go to the happy part of this talk. The happy part is you can actually get better at reading code. And step 1, I think, is recognizing these different forms of confusion and understanding that all these different forms of confusion have different solutions. So if you're reading code and you run into a long-term memory issue, you encounter a concept, a variable name, a syntactic construct that you don't know, I'm like, stop. Don't plow on, especially if it's many, because one, maybe you can get from context. But if you're like, oh, I don't know any of these concepts, I don't know any of these syntactic constructs, stop and look them up and make sure that your long-term memory, not immediately, but in the long run, gets to know the relevant terms. And you can practice it actually. Syntax and syntactic concepts and programming constructs, you can practice this. And one of the really nice ways I describe in the book as well to practice is that you can have something called flashcards. So you can have a card, like a business card, and then on one side you put one thing, and on the other side you put another thing. So if you're learning APL, you can say, well, on one side I put T, and on the other side I put encode, because it's actually not a T, it's an encode, and then what it means. And if you already know Python and you want to learn JavaScript, then you can put Python on one side and JavaScript on the other side, and you can teach yourself. And I'm seeing someone in the chat saying, yeah, you can use the Anki or Anki app. Yes, that is indeed a fantastic app. If you want to do it not on paper, but you want to train it in your phone, this is the same thing. And I know that the Anki app has some Python decks that you can download, but also there's great value in making your own deck, because this is the first step in remembering, is also figuring out what you don't know yet. So practicing syntax is actually very important. And this is something we don't do as a community, right? We always say as a community, like, oh, you can just look up syntax. Oh, well, it doesn't matter. You don't need to know anything. You can just Google, right? But that is, can I say bullshit? That is bullshit, right? Because this is also true for numbers and letters. We can say, oh, you don't need to know any reading because there's just 26 letters in the English alphabet. You can just look up a letter if you don't know it. You see how impractical that is? Or with words, like, no, just not know any words, because you can just look them up in the dictionary. You see how slow that would be, right? You really, really need a good vocabulary, because every otherwise, nothing will be catalog's cake for you. So you really, really need this practice. And people that tell you that you can look everything up, they give bad advice. Let's look at this code. So here, the confusion is really different. So the solution is also really different. If you're not a Python programmer familiar with this type of construct, then what you can do is you can actually rewrite this. You can say, this to me is too confusing. I'm going to refactor the code to be closer to my prior knowledge. So if you are a Java programmer, then this form, these two code snippets are exactly the same, do the same thing. You can say, well, I will restructure it in a way that fits my prior knowledge better, because the second code snippet explicitly creates a list and explicitly loops over the list and explicitly, using an if statement in a more familiar form, filters out customers. So you can just take the code and say, this is confusing. I will just rewrite it once, and then it will be closer to my prior knowledge, and it will be easier to understand. And I call this actually in my book a cognitive refactoring. So it's not a traditional refactoring because it doesn't necessarily improve code quality. Some people might say that it decreases code quality. So this is why it's a refactoring with a different kind. It's a refactoring you do to bring something closer to your own prior knowledge. Someone in the chat, by the way, is saying flashcards doesn't help at the beginning when you don't have any basic understanding and you have too many things to remember. Yeah, that's a great point. So in the beginning, you do want to have a small set of things that have some meaning to you, because just learning random things can be really hard. And also it can be an issue for motivation, of course. Like why are you learning all this? So it has to be a bit of a mix between practicing and learning the words or the syntax. So this is also something that's totally like fair to do. And if you work in a team with people that have a little bit of maybe less knowledge about cognitive science, they might say, oh, you're destroying the code base. But this is also, don't listen to them. It's actually good to massage code in a way that works for you. And of course, you don't have to commit this back to GitHub, right? You can leave it on a branch for your own understanding and just merge main in there. And once you learn everything, you can always roll it back or just do away with it. Someone says, yeah, comprehensions are the best part of Python. I agree, Steve. I also very much like list comprehensions, but I also appreciate the fact that new people that come into my code base might not have that background and might struggle. So there's a bit of a tension there between what I like and what maybe future contributors to a code base or future colleagues might like. It's always it's always hard in general, to think of what other people like and not just do what you like yourself. At least this is hard for me. Let's go to the third form of solution, and then to the third type of confusion with the third form of a solution. If your working memory is really full, you can actually support it. So if you're reading code that's very confusing, then you can look at it and you're like, okay, this is too much. I know I will not be able to grok this at once. This is fine. This does not make me a failure. I just need some trainer wheels, something to help me. So one thing you can do, there are many things you can do, but one thing you can do is you can make a little state table. You can say, okay, I'm just going to manually go to the code. In these first lines, what happens? Okay, this is just the value for each variable. Now the loop goes. In the first iteration of the loop, these are the values. In the next iteration of the loop, these are the values. And that way you try to gain an understanding of what happens. And there's many, many more exercises you can do to support your working memory. We have a lot of exercises in the book, but the basic idea here is that at one point you realize that you're sort of full to the brim. And at that point, I hope this is another takeaway I hope you get from this talk. You will not be like, I am a failure. I will like, this is fine. It's just my working memory is a bit overloaded. Let me figure out what I can do to help my memory friends on the shoulder. So this is just one thing you can do. There are many things, but the most important thing is realizing that your memory is full. Someone is saying, I do this a lot, a cognitive refactoring. Yes, this is very true. I am very sure that I didn't invent the idea of a cognitive refactoring. That this is something that many people do, but I think it really has a value if you give it a name, and especially if you work in a team where other people also have this vocabulary. Then if you're maybe pair programming with someone and you encounter code, you can say, okay, wait one sec, because I want to do a cognitive refactoring for me at this point in time. If this is something that people in your team know, then it's just nice to have a term for something you already do. Someone is saying, yeah, working it out on paper is definitely a way that you can help your working memory. So I think we're going to wrap it up a bit so that there's time for Q&A if you want to. I think the biggest takeaway of this talk is that if you understand your own understanding and you also understand your own misunderstanding, it will make you a better programmer, right? It will help you understand, why is this code hard? And it's really, for me, this journey has really given me this difference between I don't understand this, I'm a failure, and I don't understand this yet, and I have the tools and techniques to actually going to do this better. There are many other techniques from reading education that you can apply. Actually, there's nice techniques where you look at a certain code snippet for a very brief time and then you take it away, just like we did with the short sentence. And then you train yourself like, oh, what parts did I remember? And there might be parts coming from the short-term memory, and there might be parts coming from the long-term memory. So there's so many exercises that we can take away from natural language reading to improve code reading. Another thing that you can do is you look at a piece of code and you try to summarize it. Take like what is the goal of this code? What decisions were made? And you explicitly train yourself to write these little summaries of code. That's also a really good way to explicitly practice code reading. If you want to know more, what you can do is read my book. It's called The Programmer's Brain. I'm sure we can put a link somewhere, but the easy link is felienne.com/book. And it has many practical exercises in addition to the cognitive science background. So we covered more or less chapter 1 and a bit of chapter 5 in this brief video, but there's a lot more. So if you are interested in this type of thing, then my book might be interesting. What you could also do is what we're experimenting with is deliberate code reading clubs. So many people around the world are joining me in this initiative and they're starting code reading clubs. So together with a bunch of people, they take a code snippet, doesn't really matter what code snippet you pick, they just read it together and they discuss their findings and their prior knowledge and their limitation. So this is maybe also something you in this group, a bunch of you could get together and read code together explicitly and see what it brings you. So that's more or less everything I wanted to talk about. Let me summarize because it is early or late, depending where you are, and I might speak slightly quickly. So let me take you through what we talked about. We talked about reading code and how, as a programming culture and community, we have always emphasized figuring stuff out, and we've not emphasized deliberate exercises for anything, including reading. But if you know how your brain works with those 3 memory systems, you can actually get better at code reading by practicing syntax to help your long-term memory, refactoring code cognitively to help your short-term memory, and supporting your working memory if you feel that it is too full. If you want to know more, I'm on Twitter, as I said. My website is very conveniently myfirstname.com. You can go to felienne.com/book to buy the book, or felienne.com/club to find more information about code reading clubs. One Q&A that I often get, so I just put it in the slides because it's easier for everyone, is, well, what about the children, Felienne? You went to that programming club and then you were failing kids, and then what did you do? You wrote a book for adult programmers, like for professional developers. How is that helping kids? Well, at the same time that I was writing the book, I actually also started to work on a programming language for children called Hedy. And Hedy takes everything I know about cognitive science and puts it in a programming language. So they're very interesting. They're like, this is a whole 1-hour talk. So I'm not going to do everything about Hedy. But the whole idea is that we don't overload the working memory by not giving kids access to everything of Python, but giving them access to a small, simple subset and then gradually expanding the subset. And as Ramon already said in the beginning of the talk, another thing that's really interesting and inclusive about Hedy is that you can program in your own natural language. So it doesn't have to be English. You can also use, we have now translations for French keywords, Spanish keywords, Hindi keywords, Arabic keywords. So even if you're in a right to left language, you can program Python in your own natural language. And that is, of course, someone in the chat at the beginning of the hour was saying, well, I was struggling with English when I was learning to program. Yeah, fair enough if it's not your first language. So if you're interested to check that out, you can go to felienne.com/Hedy. It is free and open source. So it's really meant to be inclusive and available to everyone. If you liked listening to me and you want to listen to me for hours and hours more talking about programming and software engineering, this is possible because I'm one of the hosts of Software Engineering Radio, an IEEE podcast for software professionals, talking about all sorts of things, like from databases to programming language design to soft skills as well, like pair programming or doing code reviews. We're on Spotify and iTunes also for free. And with that, I think we can go to Q&A. Carlos was already saying, yeah, what happened to them? Yeah, well, some of them dropped out, but some of them waited until I finished Heidi, and they had great fun with it.
That was wonderful. Thank you, Felienne. Oh, that was super cool, and I kept trying not to, to talk too much in the chat because I was so captivated. But like, yeah, my journey with teaching kids was very similar to what you described. So I felt it. I felt it viscerally. It was great. Yeah, folks, like please throw in your questions. I think some of them got answered as the talk went through. For example, Ivan was asking, "Is there a book for this?" And it's like you just as they were asking this, you mentioned your book. Um, yeah, it's a hard problem. It's a hard problem to
Yeah.
to especially to start. I think Carlos was pretty vocal with this, and I'd love to share something he says here. Um, I think that's a problem to learn without a teacher. Too much beginner stuff, mostly the same, but not much between that and advanced stuff. And that's something that we hear about a lot, don't we? About like that sort of tutorial, getting stuck in tutorials.
Yeah. Yeah, I think this is very true. This is also what we saw with the kids in the programming club. Like initially they were doing Scratch with the blocks, which is nice and engaging and easy. And it gets like, oh, I got this. And then they make the jump to Python, and then it's really hard. And also
Yeah.
sometimes if you want to learn programming, you have this natural stamina, right? I want to learn programming. So everything's
Yeah.
failing and I get error messages and it will be fine. But some kids also, they don't know if they want to become a programmer. They're also there to figure out if this is interesting to them. And
Mm,
then too much beginner stuff is boring and they think this is boring. And too much advanced stuff is that they're like, oh, I will never learn this. I'm not good enough. So yeah, also this gradual, taking people on a gradual story might also help them to understand, oh, this is fun and I can do this and I see where this is going. Yeah, the
yeah.
missing middle is what Jaslyn calls. I really like that as a term. I was not aware of it.
Yeah. So let's see. Okay. Phaedrus is asking, having learned structured programming, Turbo Pascal, Fortran, and Perl, modern JavaScript appears extremely weird, especially grasping object-oriented programming. Is that normal?
Yes, this is entirely normal. I have a chapter in the book about how to learn a second or third programming language if you already know one programming language, because that path is also different, right? What I see is that
Yeah.
sometimes if people already know, and let's say Turbo Pascal and Fortran, then if you take a JavaScript course, then part of it will be super boring because they will explain what is a loop, what is a variable, and you're like, I know these things. But then the syntax is weird, and then conceptually at one point also stuff might get weird. So yeah, I can't summarize the whole chapter, but there's lots and lots of research that we know how to learn something that is slightly different from what you already know. And this is the idea there is called transfer. So transfer is if knowledge becomes useful in a different domain than where you originally learned it. So if you are Dutch and you're learning German, there's a lot of transfer because the grammar is the same, lots of the alphabet is the same. But this is positive transfer. But there's also, this is what you describe, negative transfer. So in some ways, like in German, a lake, the word for lake means sea, and the word for sea means lake, which is super confusing to Dutch people. That's negative transfer. I'm like, oh, I know what this word means. It is sea, and then it is lake. And there's lots of these false friends where you're like, I think I know what it, so I don't look it up because I think I know what it means, and then it doesn't. And that's negative transfer. And there's lots of things you can do to use positive transfer, to increase the chances of positive transfer, and to dampen the limitations of negative transfer. My book has lots of practical exercises applied to programming.
Wow, you just brought me screaming back to my high school French final when they asked me the word for health, and my brain went to Spanish, salud,
Ah, yes.
which means which, if pronounced correct, almost the same as like a very casual hello in French.
Yes. Yeah,
Interesting.
and that's the trouble because you think you know it, and then it is
Yeah.
still wrong. Which is worse. If you don't know something, then at least you don't think you know it, so you might look it up or not, or refrain from using the word. But if you think, oh, this is what it means, and we see this in programming as well. I myself made the transfer from C# to Python, And then they are both object-oriented languages, but really different. So it's like, oh,
Mm.
object-oriented programming, I know this, classes, methods, sure. I'll just write an initialization constructor. But then in Python, everything's at the runtime, and it is spectacularly different from C#. So yeah, I feel your pain.
Yeah, no, and it's super common. So thank you for answering that. Got another question
Yeah.
here from Zolatube asking how do we manage coding and hectic family management?
Yeah, I think this is a bit outside of my area of expertise. It's like I solved this problem by marrying a software engineer, and then we can manage our code bases together. But I appreciate this is not something that's realistic for everyone. So yeah, no, this is just really hard. So there are some tips in the book. So we know that interruptions are very, very harmful, right? And I imagine that if you have little kids running around, interruptions are very common. So something we do talk about in the book is how to deal with interruptions. What are things you can do to sort of freeze your mental state, freeze your working memory as it is, so that later you come back and you pick it up. Like this was literally happening to me before this talk. I was programming before I was giving this talk, and my programming flow was disrupted by me having to give this talk, which was a bit annoying, even though I'm enjoying it now. It's like, oh, I'm not finished. I'm almost finished. So then what I do is in the code, I write a little story to myself. I was like, this is what you were doing, and here are the next steps to get back into the flow. So this is not, it's not a magical wand. It's better to have no interruptions. But if you do have interruptions, there are things you can do to just help you reach your save point quicker, because what you don't want is coming back to the code and then you're like, oh, what was I doing 3 days ago? This takes lots of energy to get back in it. So you can do things to lessen that energy, although it will always be a bit of energy.
That's excellently put. Thank you. Let's see. We got a comment from Steve saying, in my experience, having someone one-on-one is important. I often watch people go through
Yeah.
programming lessons and they'll just miss some detail that turns out to be important. When I'm watching, I can point out to them what they missed or misunderstood, but without someone there, it could be a major derailment for learning. It's also why I think you can never make a perfect course or
Yeah.
book. And that's it. Actually, I would love to sort of segue from this. I don't want to take over your comments, Steve, but I'd love to segue into a question of my own, if I may. Um, what's your take on like something I often find myself thinking, but I have to admit I'm not formally educated, is that folks learn differently. I'd love to know what your take is on that, because I could be passing on
Yeah.
wrong
So yeah.
information.
So yes. Yeah. So yes and no. So you
Yeah.
definitely learn different based on prior experience. So someone that doesn't know JavaScript, or someone that comes in from C into JavaScript, they will learn differently. So there's definitely differences. There can also be big differences in how comfortable people are with failure. So some people from their culture or from their gender might be very scared of failing, and this might lead them to such different behaviors. But there's also this thing about learning styles, like some people are a visual learner and other people are a textual learner. That seems to be largely debunked. So most people that are beginners with the same prior knowledge tend to learn in the same way. And I think I want to pick out from Steve's remark that having some one-on-one is important. And I think this just goes back to what I said earlier in the talk, that many of programming assumes that you can learn programming without a teacher. That's sort of ingrained in everything we do, everything we say has this undertone of, well, I told myself when I was a kid, so other people also don't need a teacher. And I think it's really good that you're saying, which I entirely agree with, that yes, some people are able to make it on their own, but many people drop out if they don't have this moment where this missing middle, someone guides them to the other side. This is just very true, and I think we should stress that more.
That's awesome. Thank you. Okay. We got a question here from Naraku saying, I would like to ask, in terms of good reading code, is it better to write comments on, let's say, every second line of code, or make a big chunk of describing text at the beginning of a function?
Yeah, so there's no really right or wrong answer there. I like to say that, like, there is no clean code is a bit of a dangerous statement. There is no clean code. There's only code that is like clear to a certain person at a certain point in time. So a bit understanding of what your context is there. If you're programming by yourself and the language is still really hard to you, by all means, put comments in every other line. Because if you're going to continue the day after or the week after, this will be helpful to you. And if you look at my open source code, which you can do for the heady programming language, the very difficult parts of my code base where I do weird things, like the code I was working on this morning, I catch a certain exception from one library and I raise an exception in coming from a different library. That is a weird thing to do. I know that in 3 weeks I will not remember why I was doing that. So they're putting comments on stuff that is confusing to you, which for me might be this weird exception handling, but for you might be beginning JavaScript if you're an early programmer. Yes, there's nothing wrong with that. If you are in a code base with different people, things change a little bit, because people that already know everything might be distracted by the comments. They might feel that they're too long. Actually, yesterday I was on a podcast and I was fantasizing with the podcast host that wouldn't it be nice if different people could have a different view on the same code base? Like you put it to expert mode and all the comments disappear, but someone else can. But at this point in
Ooh.
time, we can do that. So there's really nothing wrong with putting comments there if they're helpful, as long as you're not annoying teammates that might also be working on the code base. It is a really good way to store your memory, to offload your working or short-term memory.
That's really interesting. You know, a bit of a side note, if I may. Something that was quite common in the Ruby community was this sort of notion that good code documents itself. And so if you're writing comments, then that was a yep. I'm so glad that you're giving that the thumbs down, because like, yeah, if you're putting in comments and then you're doing something wrong, and it's like, no, like the comments are there to help us.
Yeah, and there's so many things that you cannot put in code, right? This example that I was just giving, this is a great example. Like, why am I wrapping the one exception in the other exception? How is the code going to explain to me why it is doing this, right? And the reason is I want to have all exceptions be similar. So there's already another library. My parsing library gives me an error, but I care about consistency, right? So the code is not going to tell me that I care about consistency. So I put this there explicitly. I do this because I want to have all my exceptions in one place in the code for future readability. And sometimes also you're checking for, I don't know, package loss or something. You can say there, we do this for mobile users. This is why it's important, because someone else might come into your code base and like, oh, why do we do this? The code will never really have the why there. So some comments are really important. And then that's even not even taking different types of prior knowledge into account, right? That it is self-explanatory to me, someone that has 20 years of experience in designing programming language. That does not mean that if random people on GitHub want to contribute to my source code, it will also be understandable to them, right? And I cannot expect that. I cannot be like, here, take these 5 compiler courses and then come back to fix a bug. This is not really helpful for anyone.
Yeah, thank you. So we got another one from Carlos asking, Felienne, do you recommend to try and understand the JavaScript logic on any site page as a practice, or is that crazy when you are a beginner?
It's definitely not crazy. So if you propose this, I think it's something you will enjoy, because otherwise you would not be proposing it. So some people might feel that it is intimidating. If it makes you scared and makes you feel like a failure, then please stop, because it will be hard. But if you think this is something you might enjoy, absolutely go for it. You might want to choose a website that is limited in scope, maybe 100 or 200 lines, just to not overwhelm yourself. And I would definitely recommend, I'm pitching my book, but in my defense, it was a lot of work to write, so I want people to read it. But my book has many concrete things, concrete exercises that you could do. Because I would say just reading the code, what might happen is you read it and then you're at the end and then you're like, okay, I read it. Have I understood it? So we have very concrete exercises in the book. For example, what you could do is you could circle all variables and then you print it on paper and then you link the variables to where they're used. So, oh, here's a parameter, this goes into this method. And that gives you a view on the code. And another visualization that you could do yourself is you can circle blocks. You're like, okay, here I have a loop. Here I have a condition. And those are things you can do to help yourself gain an understanding. List all variable names. It's something you do really mechanically. You go through the code, all the variable names, you put them on a piece of paper. And then you're like, okay, do I understand this word? Can I guess from context what more or less happens there? So these are all different exercises. So I would recommend that you do these exercises over just sitting down and reading. But it's really not crazy. I think it's a really cool idea. As long as you don't bum yourself out, you're not like, oh, I will never learn this. Now I'm sad and I will quit the bootcamp because I feel that then if you're going there, then it's not a good idea. But if you have the the failure stamina to do it, yeah, it's a great exercise. You can totally do it. Go for it, Carlos.
I love that term, failure stamina. It's something that I feel I have to deal with a lot myself. Yeah. Well, folks, like this has been absolutely wonderful, and I don't want to take up too much of Felina's time. Y'all have asked such good questions, so I really appreciate it. Yeah, this has been wonderful. Felina can like, without of course respecting your time, could I tell folks that if they want to get in touch with you, they can find you on Twitter at Felina?
Absolutely. Feel free to reach out or send me a message if you want to read my book, if you're enjoying it. If you're not enjoying it, definitely let me know.
Awesome. Yeah, I gotta check it out myself. And I heard of the code reading clubs, and I kind of want to get into that as well.
Yeah, we have so you can see it on my website, but we have a monthly free online session every first Tuesday of the month at 7 p.m. Central European time. So this is also quite accessible for people if they're in the US, because then it's daytime. We prepare a piece of code. You don't have to prepare anything. You just log in and we guide you with exercises through the course. This is free every first Tuesday of the month. You can find this on felienne.com/club. And we're very, very beginner friendly because we do different programming languages. Like 2 weeks ago, we did Elm. I had never seen Elm. So I'm a beginner like everyone, right? We've done Rust. We did TypeScript last week. So it's really very beginner friendly because everyone is a beginner in a language. Like I've never done Java. If I see Java, I'm like, So very beginner friendly. Definitely drop in if you want to.
I've done a lot of Java, and I also get that way. Just because.
No, maybe it's not me. That could very well be possible. I hear that about Java.
No, thank you for providing all these things, Felina. This is wonderful. Steve says never done Java. I'm so jealous.
So jealous. Yes, well, I've done C#, which is kind of similar.
Well, I'm gonna let you all go. Enjoy your morning, enjoy your afternoon, enjoy your evenings. Felina, again, thank you so much. This was extraordinary. And folks, thank you all so much for joining. And yeah, wish you all a wonderful day. And see you next time. So for the boot campers, we're gonna be back on Monday. Web development and JavaScript. So take care, everybody, and see you next time. Bye now.
Bye-bye. Thanks for tuning in.